I'm going to show you some techniques for the presentation of readouts and discussion. 5 principles for writing readouts and discussion. The first is relevant. Relevant to what? Relevant to the objectives. These readouts are presented around objectives. Because you had objectives, you want to use evidences to prove that you met your objective. Again, it must be clear and plain because clarity is always essential. And you present in the right order. Okay, what kind of order? You present it in the order of importance. You begin with the most important, followed by the less important, and the least important will be presented at last. It's different from the way you present methodology. Okay, you present a methodology in the order of time. If you accept the limitations, which means your work is not perfect. Okay, you may not meet the objective 100%. And you present some limitations so other people can follow your work. Okay? And it shows that you are the expert who understands both sides of the story. Last, but definitely not the least, engaging your readers. When you present your readouts, your readers may have a lot of questions to ask. I would anticipate the questions, the challenges, then I write down the answers. When you present the readouts, you also attempt to engage your readers as much as possible. I'm not asking you to answer all the questions because that's infinite. But answer the questions, anticipate the questions or the challenges which are relevant to the objectives and in the order of importance. I had 5 principles. That's more like what I want to be when I write. You want to be the good writer. But how? The first technique is very important, which you wouldn't miss it anyway, because when you present a readout, you always try to do that. What is reiteration? Reiteration means you present something by highlighting the importance. Okay? It's like a retell the story. So that this step, you are going to integrate visuals with the text. That's only the beginning. Okay. After you explain your readouts, you need to tell people why they appear like that. Then you may explain to your readers why your data is trustworthy. How do I know your readout is valid? Then you got to validate your readouts, get your readers. Okay. How do you know your readouts are accurate? You can do that by comparison with other people's work, or you also can compare internally. That's a part of the analysis. So this is the discussion part. And at the end of the day, remember your job is to create or deduce new knowledge. You want to contribute to the field. Remember, your job is not to report to your supervisor. Rather, you report to the society with your new knowledge. Then how do you get the new thing out of this? You have data. These are the data. You want to get the new knowledge. To do that, there must be some in-depth analysis. After the analysis, you may have some limitations. I already mentioned that, but you have to present them. Again, these are the readouts presented by the native speakers. The article I showed you by the Cambridge University and the University of California. Okay, this step is called reiteration. Let me show you what reiteration means. Figure 4 shows oxygen over carbon, oxygen, carbon, nitrogen, carbon, nitrogen, carbon. The ratio of these peaks, okay, for clarity, this you wouldn't tell, and their molecular mass. This is the molecular mass. For both stages, water stages. Okay, you see that? So that's what the reiteration means. But not there yet. You got to continue. From the figure, I can see stage 3 is in blue and stage 8 is in red. But you have to say it in the text. So that's called reiteration. You got to clearly explain the legends and content although they seem to be straightforward. So readers can understand most results by looking at the figure, sometimes it's a table, or the text separately. Okay. Now, if I go back to this one, you see, if I cover up the figures, you should be able to imagine how the figure look like. If I cover up the text, you should understand 80% of the content in the figure as well. However, you see, most people stop right here. Okay, these are the results. But the results is only the beginning. Discussion really matters. Okay, you've got to continue from there. Okay. Then the authors continued on figure 4a, right? The first part is reiteration. Figure 4 show. Whatever in the figure, you need to reiterate. Then you need to do some analysis, not just the results. You can explain why. Why do they look like that, right? This is due to, you see, the explanations, right? So then you have some knowledge, maybe from your methodology, explain that. Similarly, you also compare stage 4 only 50%, 45% are in math. In comparison, you compare them. Of course, by the figure, you cannot tell 57. That's a very accurate, right? 55. So those are from analysis. You must get the original data to analyze this one. Then this is the reiteration, okay? And then you have explanation. This is the indicating, in mind, this is for the beginner. How to write a reiteration, integration, explanation, and maybe comparison. You start with figure shows. Okay, try not to say this, that are showing in figure. No. And then you can say something was found to. Then when you do comparison, in comparison, if you explain this is due to, this is due to, then indicating, that means there's analysis indicating the presence of something or the importance of something, depending on research. Okay. Now we move on to the fifth technique, which is in-depth analysis. So you had the data from the previous paragraph, okay? You now do further analysis. You see, for all compounds below 150, in stage 3, the N is clearly correlated with, okay? And it provides with particle loading and wind speed. If you remember what's in the figure, there is no any information about particle loading or wind speed. But the figure 4 does not show that. So you move on from figure 4, you did some correlation. Okay, that's analysis. How you do that is in the supplemental information, but that's okay because this article has a page limit. Okay, but you can see that you are not only reiterate the figure, but you also do some further analysis. Okay. Then you have a keyword here. This suggests. So you are getting the new knowledge here. By the correlation, you get new information. Okay, then you say this may be soil derived. Okay, then you explain it. However, you are not very sure. You want to continue analyze. Soil organic compounds are known to be something, have a large number of nitrogen content from this literature. Okay. Only one sentence. You use this one to support this suggestion. That's how you use existing literature to support your new knowledge. Challenge is you cannot only rely on your own data or your own readouts to support new knowledge. You must read a lot, support with other people's work as well. The sampling location, remember location? There were 1,200 cows, right? That's how the location matters. So again, you use this one further support your argument. You from your own data, from literature, from your methodology. You see how you support one simple conclusion with three angles. One is your correlation. Another one is data in literature. The third one is your methodology, which justifies the source. This correlation is not as strong if all components. That's basically a further explanation, but that's not supporting. That's just like a side observation. Again, that's how you write readouts on the discussion. It doesn't have to be long. Don't drag very long, but get to the point. This is a perfect example for clarity. As shown above, it is often difficult to identify this or that. So this is the first analysis as compared to every other formula in the entire dataset. Then it conducted linear regression analysis used by comparison, by linear regression analysis, and later on it used correlation. You see, the results, this result is in a number set of correlating species. There are three of these correlating or those supplemental, which gives the formula. Okay, so all this just repeats what they did, just like an extension to show you how they are related. For beginners, analyze your data, then you have a suggestions, or this suggests that. Okay? Then you use existing literature to support that suggestion, and you could partially explain that because of this, all pointing to this suggestion, but you have to analyze. Then you can allow the possible identification of something, then something was compared to the others. This analysis assumes, because it's a further analysis, there must be some assumption which gives some results. This results in something. Okay, so you do not stop at what you collected. You must use those data for knowledge. It's a similar practice by normalized. You see, even normalized against something, it indicates that's the result. The results only compound. Also series show something. In contrast, you get something else. And there's also a positive correlation. The position series also correlated, again, suggesting that maybe soil derived from local farm sources. Okay, continue. And however, I want to highlight this part. No series correlating were identified by this method. So basically, there is a method, but not identified in stage 8. This indicates for smaller particle fractions. That tells you there is a limitation for this research. So you accept the fact that there is a limitation, because it's the instrument. The instruments you use may not allow you to detect all the particle composition in the small particles. Many students would hesitate to present this part. They consider this as a negativity. I really encourage you to present this limitation. The reason is, as I said before, it demonstrates your professionalism. You understand this. You know what you're doing. People trust your results. Your followers or your fellow researchers who read your article would know, this is important and this is not done yet. I'm going to do this. I'm going to follow this research and continue from here. You get it? Basically, when you put this limitation down, your contribution is pointing the direction in this field. That is actually more valuable than the result you presented. For beginners, how do you write the limitations? You can say something was not identified. You say no, was not identified. So indicating either complexity or most of the time, I would write the need of further research. So you also can say something is needed. This is the complex. I remind you, when you write your readouts and the discussion, try to be explicit, stating explicitly your opinion. Although sometimes in some culture it's not welcome to be that straightforward, but in English writing they are straightforward, just clear, state clearly. However, your statement should be followed by a logical argument. Readouts and the discussion. Remember, there is a and, not just readouts. Okay, a typical mistake is lost in translation. For example, the figure shows that the difference between whatever concentration gradient within was negligible. When I look at this paragraph, I see the difference in gradient, which means negligible is wrong. From here to here, you have lost in translation. Then I gave him the suggestions, that is why in technical writing or to present the data without a WAG was significant. You must present the data. Another typical mistake, figure shows then without integration, right? Similar here, there's a table, you only have one line, there's no reiteration. Anyway, reiteration should be clear so people can understand you